Well, welcome back. Here to talk about the tar pit, how to avoid it in the first place, and if you're stuck in it, how to get out of it. My name is Ernesto Tagwerker, and you can find me on Twitter, GitHub, anywhere with the handle eTagwerker. My pronouns are he, him, his, and I'm honored to be here in the code quality track. So I'm originally from Argentina, so if you hear an accent or a weird word, it's because English is not my first language, so I'll try to do my best. I have been living in Philadelphia for the past 3 years with my wife, daughter, and I love open source. I wouldn't be here today if it wasn't thanks to open source. A lot of the code that I'm going to talk about was written by other people, maybe some of you out there. Actually, maybe like 5% of the code that I'm going to talk about in this talk, I wrote myself. And it's basically just gluing other open source libraries. I'm the founder of a small software development shop called Ombu Labs. We like to work a lot with Ruby, Rails, JavaScript, and open source. We try to give back to the community as much as possible through a bunch of gems that you might have heard of. Now, a few years ago, we found ourselves working a lot with Rails upgrades. And we thought, why don't we make a service out of this? And that's how fastruby.io was born. It's basically a productized service that helps companies upgrade their Rails applications in a few weeks. Now, the problem with this is that we get a ton of projects that are not ready for an upgrade. So a lot of the insights I'm going to share with you today come from our experience doing Rails upgrades, but also assessing code quality very quickly. We spent 1 week doing a code dive into our clients' projects, and then we decide whether we take them or not, because we're never going to do a Rails upgrade for a project that has no code coverage. So that's one of the things that to keep in mind. Now, when I'm not working on Ombu Labs or fastruby.io, I like to maintain a few gems. Database Cleaner is a tool that helps you clean your database between test runs. Bundler Leak is a gem that lets you find leaky dependencies in your application. There's a known database of leaky dependencies out there, and you might be using one of them. So Bundler Leak does help you with that. And NextRails is a toolkit that will help you find incompatibilities between your current version of Rails and your next version of Rails. And it will help you do things like dual booting. Now, the inspiration for this talk is this book that was published many, many years ago. It's called The Mythical Man Month. And the very first chapter talks about the tar pit. And Fred Brooks here talks about this prehistorical scene where bees would get stuck in the tar pit and struggle to get out. And I really like this quote that says, "The fiercer the struggle, the more entangling the tar, and no beast is so strong or so skillful, but that they ultimately sink." And then he goes on to talk about large system programming. And to be honest, this book was published in 1975, and today we still have the same issues that are written out in this book, minus the mainframe problems and all that. So you can replace large system programming in this phrase and replace it with cloud computing or minimum viable products development. Fred Brooks is also the author of No Silver Bullet, an essay that is great. I recommend you go read it if you haven't already. And in that essay, he talks about our problems not being solved by one technology, because our problems in software engineering they're not technological per se. They're more about processes and communication and teams and people. So going back to the tar pit, I think we're either in two states. We're in the tar pit right now, or we're trying to avoid it. And if we are in the tar pit, we're trying to get out. We've all inherited a project that sucked. And we're like, yeah, I'm going to pay off technical debt, and it's going to be awesome. I'm going to make it awesome. And then you go into the project, and you start doing your best, trying to refactor. And the more you refactor, the harder it gets. And yes, to bring it back to modern world, The Simpsons always have a gift for this. And that's what it looks like. So to bring it back to reality and to stop talking about an analogy, the tar pit sometimes shows up like this. Projects running over budget, saying you ship something in a month and then 6 months in, you don't know when you'll be done. Taking forever to ship small changes. Telling your boss, yeah, I'll ship this change in a week, and then a week goes by and your boss is like, so when is it going to be done? You're like, I have no idea. And then the classic, sacrificing quality and increasing tech debt to be paid off later, but then later never comes, and the tar pit just gets stickier and stickier. And to bring it back to reality and to a current GIF, we can look at this. And we're all familiar with this, but it's not fine, because this is messy, and you don't want to be in a project like this one. So, yeah, the first thing you can do is avoid such projects, right? You'll be in this situation where boss comes up to you and they tell you, yeah, if you could come in on this great legacy project and maintain it from now on, that'd be great. For us at fastruby.io, it's basically a client who has a Rails project that is totally out of date and they need us to upgrade it. And the problem with this is that if you agree, if you say like, yes, I will maintain this project, the next question you'll get is this one. How long is it going to take to ship this small change? And of course, the next comment will be, because I need it by end of day today. So you'll have to quickly assess code quality before you commit to maintaining this project. Sometimes you'll be able to say no, and sometimes you'll have to maintain it, which will suck. But that's what part 2 is all about. Part 2 builds on top of part 1 and uses some of the tools that I'm going to talk about in the first part of the presentation. And I'll address this question: how can we gradually pay off technical debt? All right, so let's get started. Part 1, you get to work next week and boss comes up to you. Yeah, Carl quit, so he's the only one who knows how to maintain the legacy system. It can't be that hard. Go figure it out. And of course, Dilbert ends up stuck in the tar pit. In our industry, it looks like this. It can't be that hard. It's a Ruby project, right? Ruby was designed with programmer happiness in mind, so it should make you happy, right? Well, yes, that was the vision, but then we came along and used Ruby, and some projects just don't spark joy, okay? So how can we quickly assess code quality? Well, there are a bunch of ways to do it. The main ones are you pay someone to do it for you, and you can use Code Climate, Codacy, CodeZine, or you can use a free and open source gem to do it. So for the sake of this talk, I'm going to talk about open source gems, because even the paid services use some of these gems to give you the score for the application. And these gems do a bunch of things for you. They do static code analysis. So that means that they read every single line of code in your application, and then they assign a complexity score to every single file. So you can see the complexity in the total complexity in the project. Then there are tools that will calculate code coverage for you. They will tell you your test suite exercises 80% of all your code base. And then there are tools that know all the code smells that are out there in the world, and they will compare a known database of code smells with your code base to tell you how smelly your code is. And then you'll get a good picture of software quality in your project. And of course, what is software quality anyway? I think we don't talk about this enough. So unfortunately, there are hundreds of definitions out there. There are books written about this. There are models written about this. And I'm going to focus only on a few definitions. The first one is by the IEEE that says, it's the degree to which a system component or process meets implicit and explicit requirements. And sure, there was a committee that got together and came up with this definition, which is totally accurate. But next week, you need to maintain the project. So this to me sounds like it works as expected. But this is not software quality, in my opinion, because I need to maintain it. So to me, it works as expected, and it is not a pain to maintain it. Now, to see another definition, we have the ISO 9126-1. Please don't fall asleep. It's very short, which talks about 5 different aspects of software quality. And I want to focus on maintainability, because that's what we're going to do. We're going to maintain the project. So when I talk about maintainability, I like to talk about 2 aspects, and the order here is important. I think the first one that I care about is code coverage. Like how many statements in my application are executed by my test suite. Now this is key because it will affect the next one, which is code quality. Now I will find complex files and I will find smelly files, and I'll be refactoring those files. And if I'm going to do that, I need tests to make sure that the behavior remains the same way while I improve code quality. Now, the good news is that in Ruby, we have a bunch of tools out there that are awesome and are very easy to set up. So for code coverage, we have SimpleCov. SimpleCov will tell us how many statements are exercised with our test suite. Now, yeah, the problem is that it won't tell us if the tests are good or bad. It will just tell us if they're exercised, which is something. It's more than nothing, okay? You can load it like this, and then load it in your spec helper like this. And here you're telling SimpleCov to track every single Ruby file and to only load SimpleCov when there is an environment variable called coverage. Now, you want to do that because this will affect a little bit of the performance in the test suite, so you want to load it only sometimes. And then you can run it, and this will generate a nice-looking HTML report that looks like this. Now, this tells us that 82% of this project's statements are executed by our test suite. And it's awesome. It's a signal that tells us something about the project. Now, for code quality, it's not as simple. There are a bunch of tools out there. There's Flog, there's Flay, there's Reek, there's Metric Foo, RubyCritic, Attractor, and there are more and more that I obviously haven't listed here. Now, for the talk, I decided to go with RubyCritic. I like this one because it's currently maintained, it is active, and it uses other gems that are out there like Flog, Flay, Reek, and recently SimpleCov. Now, a couple concepts that RubyCritic uses are churn and complexity. Now, churn is interesting. It tells us how many times a file has been changed since the beginning of the project. Now, for that, we have Git. So Git will tell us how many times a file has been committed. We can quickly do this to find out that default.rb has been changed 3 times, and then churn count is 3. Now, this metric by itself is not that interesting. It will tell us like how many or what are the files that have been changed the most. And sure, there is some value there. But it becomes more interesting when you combine it with complexity. Now, complexity, RubyCritic uses Flog to calculate complexity of a Ruby file. Flog is a gem by Ryan Davis from Seattle RB, and it's been around for more than 10 years. You can use it like this. Basically, you say flog foo.rb, and it will tell you, yes, foo.rb has a score of 10.8. It's like, okay, what, is that good? Is it bad? Well, I don't know. Let's look at it. What it does is it assigns a numeric value to every operation and every statement in the methods of all the methods in the module. So an assignment is 1.2, an eval is 6.0, and so on and so forth. So here we know that the complexity points for this project or for this file is 10.8. Again, by itself, it's a metric that will tell you, yes, this is not a complex file, but then when you combine it with Churn, it starts to become super interesting. And Michael Feathers has written about this a lot. And then Sandy Metz went on to write another article, which is super interesting. And they basically talk about this graph. This graph has in the y-axis the complexity and in the x-axis Churn. So if you have a file that has changed 2 times, but the complexity is 100,000, you'll have it in the upper left quadrant. But if the complexity is 100 and it has changed 27 times, you'll find it in the lower right quadrant. Now, by itself, this doesn't really tell you much, but when you see all the files, it becomes super interesting. So we're going to see an example with Ruby Critic. You can install it like this and run it like this. And you'll get an HTML report that looks like this. It's like, okay, so what do I do with this? Like, well, by itself, it's hard to interpret this graph. Is it the tar pit? Is it a dumpster fire? I don't know. Well, let's go and see the left side first. We have these GPA pie graph, where basically every file in the project gets graded from A to F. For those of you not familiar with the American grading system, think about 100% to 0% for a test score. So for calculating the GPA, it uses reek for the code smells, and it uses flog for the complexity of the file. And then it merges all that information into one single score. So if you look at that, you can be like, well, yeah, 60% of the project is either a B or an A, but then 25% of it is either a D or an F. So still undecided whether this is a good project or a bad project. If you look at the other graph, you'll see the churn versus complexity, and every single file in the project is plotted there. Now again, this is a lot of information with a lot of points, and I don't really know what to do with it. So it helps me to look at it this way. I look at all the files, and then I imagine this asymptote that helps me divide the graph in 4 different quadrants. Now, the first one is the best quadrant. It's like, this is the good place. You want your files to be low churn and low complexity. Then in the upper left quadrant, you'll have file, yeah, that's what it is. Like, I'm just trying to be honest here. These are files that probably work, they're super complex, but nobody touches them. So Sandy Metz has definitely put it in a better way than I have. She says, if the code never changes, it's not costing us money. So not your priority if you're going to go refactor things. Now in the lower right quadrant, you're going to find files that change a lot, but they're super simple. So you can look at them and understand them, and they're obviously not costing you money. These are files like configuration files or translation files or something that is not your priority, to be honest. Now it gets really interesting when you get to the upper right quadrant. So yeah, these modules are complex and they change a lot, and Michael Feathers says that sometimes a class becomes so complex that refactoring seems too difficult. So you know you need to refactor them, and you want to, but every time you go and try to do it, you just lose time and you can't do it in one single sprint. So you know you need to do it, but you just don't have the time. Now, when you look at this graph, you can answer the question, are you getting into a tar pit? Is it a dumpster fire? Or is it a truly maintainable project? And sometimes it'll be easier than others. Sometimes you'll look at the graph and see all the files in the upper right quadrant, and you'll be like, yeah, no thank you. I don't want to work on this project. So far we saw a couple things for code quality and code coverage. And these things are signals in my book. You have one signal for code coverage, and you have another signal for complexity. Now, they're both analyzing the same code base. So I think it's normal, it's like a good idea to put it all in one graph and say, for all of those files, you know the complexity and you know the code coverage. And then I was like, what if we could combine the two signals into one to gather insights from our code base? And I like to call this the stink score. Now, of course, the higher the stink score, the worse the file, right? And the stink score is a function of code quality and code coverage. And code quality is composed of complexity and smells. So the main idea behind this formula and this new metric is to say files which lack tests should be penalized. And by penalized, I mean you should pay special attention to these files that are super complex and lack code coverage. It's easier to see this with an example. Let's say we have foo.rb, and we know complexity and we know smells. So we multiply complexity times smells, and we get 100 smell points, let's say. Then we have bar.rb with the same metrics. So if you look at them side by side, you're like, well, both of them have 100 smell points, so foo and bar are equally stinky. Yeah, okay, you can say that because you don't know code coverage. But what if you knew code coverage for all of those files? And you knew that foo.rb has 0% code coverage. There's no test for this file. But then bar is perfect. They have perfect code coverage. You do the same math, but then you add a factor that penalizes the smell points, and then you come up with the stink score. So now you see foo.rb is way stinkier than bar.rb. And that's the conclusion you can come up with. Now, of course, this is something that you can do manually, and we've done it a lot in fastruby.io. We would basically take a project, look at the code complexity, and then look at the code coverage, and then manually cross-reference the data to produce a code audit report for our clients, which was super tedious. And you can do it, but we're programmers, right? So we came up with a calculator. And who better than a skunk to ask about whether a file is stinkier than other, right? So yeah, this is a stink score calculator. And what it does is it builds on top of Ruby Critic. So that's what I was saying, like 95% of the code in this talk was written by someone else. Skunk is just gluing metrics that are already out there, like simple cops metric and Ruby Critic's metrics. You can install it like this, and then run it like this. And so far, the report is not pretty. It looks like this. But the most important part are the files. Here you get a sorted list of files from the stinkiest file to the least stinky file. So here you can see that git.rb is the stinkiest file out there. Now at the end of the list, you also get a summary of all the numbers. Now stink score total is not that important because the more features you add, the more it's going to get to be higher. So it's only going to grow as you add features to your project. The one thing that I want to focus on is the stink score average, which is basically the total divided by the number of modules in your project. A little bit about how I came up with this number. Ruby Critic has this cost method for every module. Now this formula uses the smells that come from reek, and it calculates a cost for every smell that is in the Ruby file. And then it uses complexity, and it divides it by a magic factor of 25, which I don't know why it's 25, but it does that. And then it comes up with a total score for the file. what skunk does is it uses the cost value and then it brings in the penalty factor. So if there's perfect coverage, the stink score is going to be the cost. But if the code coverage is at 20%, then the penalty factor is going to be 80. So the stink score is going to be 80 times cost. Now, a few warnings about skunk. It is pre-1.0, and until last night, there was a major error in the formula. So feel free to go check it out. But anyway, I'll tell you, if you ask me later, I'll tell you what it was. And you need to run rake tests with coverage set to true before you run skunk, because skunk will basically load the coverage result set JSON file from SimpleCov to know which files are covered and which are not. And definitely open to feedback. I think this is just the beginning of a conversation about code quality and technical debt. All right, so right now we have 3 metrics. We have metrics for maintainability that are code coverage, quality, and the stink score. So the good news is that now we know where we stand. We know where we are in the map of technical debt, which is good, right? Because if you don't know where you are, you don't know where you need to go to. And these are the La Brea tar pits. Yes, that is correct. All right, so part 2 is all about using what we learned from part 1 and guiding us in paying off technical debt. Because let's say we are in that situation where we can't really turn down the project. So we really like our job, we like our benefits, and we just need to maintain the project, okay? So, okay, I need to ship features and I need to ship patches, and I also want to ship improvements to the code quality, right? So where do we begin? Well, a good way to start is by removing files. We all love that, right? Okay, cool. So one way to go about this is to use a gem like CoverBand. It's a gem that you can install and run in production, and it will basically track every single statement that gets exercised by real production usage. All right, and then you'll get an HTML report that looks like this, which is basically the same as SimpleCov. The only difference is that this information comes from real production usage. And this will guide you in removing files that are no longer used or methods that are no longer called. Cool. Another way to go reducing our stink score is to refactor complex files. Yeah, awesome. We inherited the project and we all want to do that, right? So we go back to the graph and we see all these files up there and we're like, okay, these are great candidates for refactoring, right? Cool, but there are 4 files there and I have no idea which one I want to refactor first. And that's when I say churn versus complexity is not enough to prioritize your refactoring efforts. And that's when the stink score table comes into play. You can basically look at all the files, and you can find the ones that do have code coverage. And you can find that, of course, you don't want to refactor the files that have 0% code coverage. That would be a nightmare. I don't do that. But you do want to refactor the ones that have 60% or more in terms of code coverage. In this particular case, we see that git.rb has 60% code coverage. So we say, okay, it is the stinkiest file, and it has decent code coverage. So you go to the graph, you find it, and then, yes, it's time for the manual work of looking at the file and analyzing what are the things that you can refactor. So one of the things you can do is split the file in 2 separate files. Let's say that you found 2 responsibilities in git.rb. Not only does it fetch data, but it also calculates statistics. So what you do is you refactor it into 2 files, which moves, basically it gets rid of git.rb, and it moves the 2 new files to the lower left quadrant. Awesome. You paid off technical debt, but how much? How much did you improve the project? And it's hard to communicate this, right? Because you can spend a lot of time paying off technical debt, and then you go to your boss and you say, yeah, I paid off some technical debt, or I paid off a lot of technical debt. We need a numeric value for this. It's like a new language to communicate how much technical debt you paid off. So the good thing is that Skunk has a feature for this. You can compare your own branch against master and basically compare the stink score average to tell you that you actually improved the project by 10%. So now you can go to your boss or to your team and say, look, in this sprint, I spent some time refactoring the file, and I made it 10% better. Another great way to pay off technical debt is to write tests, of course. That way you are reducing the penalty factor for every file. You can go to the table again and look at the files that have 0% code coverage. Now the first two files up there with 0% code coverage are just test files, so we ignore them. They shouldn't even be there, but anyway, they are. So we picked the third one, that is the rake test, that gets called all the time. And what we can do is write some tests for it and then do skunk -b master and get the code coverage percentage. Well, to be perfectly honest, this is not ready yet, but the roadmap would be to do something like this. It gets a little tricky because SimpleCop tracks everything in a result set.json file, so it's in the roadmap, but it would be awesome to be able to communicate this like that. The important thing is that now you have a stink score average that you can keep track over time, and basically every few weeks you can run the report and say, well, we're actually pretty stable, or, well, no, we are actually going up exponentially, so there's something wrong in our engineering practices. We need to be more aware of what we're doing. The main goal of this presentation is to talk about measuring technical debt and measuring the efforts that we do to pay off technical debt. It's so hard to go to a non-technical client and tell them, yeah, we paid off some technical debt. If we can have a metric to tell them we paid off 20% of your technical debt, it gets a lot easier to communicate the value of our engineering skills. And if you don't like Skunk, that's okay. You can just use SimpleCop and RubyCritic to measure the quality of the code base. And of course, like any tool out there, this could be used for evil. Yes. And please don't do that. The goal is not to power your next witch hunt or to help you point fingers at your coworkers. That's the worst thing you can do. The goal of this tool is to be your compass getting out of the tar pit. It will tell you with a numeric value whether you're actually making it better or making it worse. All right. Thank you so much for your attention. If you have any ideas or any questions that you want to discuss in the Ruby project, it's all open source, and you can just go to fastruby/skunk in GitHub. Thanks a lot to Ombu Labs for sponsoring me to be here. I wouldn't be able to speak at RubyConf without their help. We are hiring, and we are 100% remote, so feel free to check us out. And yeah, if you have any questions and we don't get to talk in the conference, feel free to reach out to me via Twitter. I'm always eager to get more ideas about the stink score and skunk. Thank you.